So welcome to From Zero to Production. This session, we're going to actually walk through defining repeatable development environments, consistent CI configuration and dependencies, and deploying predictably to production, right? And we're going to do this using a simple expression language called Nix. And I'm going to kind of walk you through the different kinds of components that allow us to do this in a declarative way and some of the core principles behind Nix. Now, there is a talk later on today in another room by Eric Merritt, who's going to be talking a little bit more about the ecosystem. I'm really going to be more focused on the problems it can solve and why we chose it at Lookout. So I work for the infrastructure engineering team at Lookout, and we started migrating from our convergent configuration management system that will remain nameless, that we've had in production in various forms for several years, and we've already migrated various services both on the product side and also internally, internal things like Gerrit, Artifactory and things like that, as well as core pieces of our product into production. We've only got about 200 to 300 hosts monitored today using NixOS, but that's going to dramatically increase by the end of the year. We have like internal Nix channels for our internal packages that we don't want to release publicly, and we have our internal binary cache. These are some of the pieces that we've had to sort of set up as part of the Nix ecosystem to be able to leverage the whole suite of tools. And we've taken this philosophical approach of having one repository per service. As you'll see on a separate slide, we have a large number of services, and we're going to be increasing that dramatically over the next year. So we need to provide service engineers and service owners the ability to use their, to self-service their server configuration as best we can, and we don't want to lock them in and lockstep them into like specific versions. So, and we're going to have the repository as our source of truth for everything, the application code and deployment code, CI code, everything. And by the way, we're hiring, so talk to me. But don't email me, because I'm not very good on email. So who am I? I started as a back-end developer 16 years ago, and over the last 4 to 5 years, I've moved more towards infrastructure engineering and trying to solve orchestration, deployments, and things like that in various forms, using various tools. And one of the endorsements that I'm very proud about is fire eating, but I don't think you should ask me to demonstrate that. Then there's also hating Jira with a passion, right? So I have 9 endorsements for that. Very proud of that one. So okay, so I also love the author of this piece, this quote. On reliability. So those that want to really reliable software will discover that they must find means of avoiding the majority of bugs to start with. Now, in many ways, this is actually very much the Erlang philosophy, right? Just because the slogan is let it crash, there's a whole bunch of the language itself is premised on not being able to make really silly mistakes, like a lot of other languages. So I think there's a lot of commonality between the Erlang philosophy and the Nix kind of ecosystem philosophy. And of course, this is Dijkstra. And he goes on to say, if you want more effective programmers, you will discover that they should not waste their time debugging. They should not introduce the bugs to start with. And so, thinking through your problem and how you construct your solutions can help eliminate a whole classes of bugs. So why care now? Why today? Why should we actually care about reliability in operations and infrastructure today? I think there's three factors, right? There's economic factors, there's human factors, and there's technological factors. So from an economic factor, we're deploying larger and larger distributed systems. And I don't just mean we have more nodes and more servers, but we have more complexity in terms of what we're deploying, how they interact with each other, and things like that. Some of these services are more problematic, right, in terms of their interactions, and we're maybe not thinking through some of those things. But we want the foundation, at least, to be solid and reliable, I think. And human factors in operations and people that are on call, there's a really high churn and turnover and a lot of burnout. And it's really expensive, actually, to keep good people. And you keep good people by letting them do their best work and not having them get called at 3 a.m. in the morning every night, right? And technological factors. Now, I think FP no longer for academics has been true for a while, right? But I think that's more of a public perception now, and that's a good thing. And then also we've got programmable infrastructure. So we have that at our fingertips now, and we can provision as many servers as we want today very, very easily. And there are many, many providers for this, right? So all three of those together, that I think that means that we should really start caring about really hunkering down on reliability and infrastructure. So at Lookout, we currently have 20 to 30 services that we actually need to allow developers and service owners to be able to self-service, right, and be able to push through changes all the way through the pipeline. And more, like we're seeing more and more services each month that are ready for production. We expect at least 50 by the end of the year, possibly more. We currently have to support a variety of stacks and runtimes. We're fairly heavily on the JDK, JRE, but we have a number of different stacks that we have to support. And we need to be able to support many types of environments, so ephemeral environments for integration testing. We also have multiple product lines, so consumer and enterprise, and they need separate environments. And we need to be able to spin up on the fly performance environments whenever people need to do those kinds of things. And partners, sometimes we need to segregate environments for specific partners of ours. And we have to support all of these things and possibly more. I may have missed a couple of these things. Now, with persistence components, there's a bit of a problem. You can't just, stand up completely immutable infrastructure and let them sort of, roll in and out of load balancers and things like that to deploy them. You actually have to think about data migration or how you're actually going to do that for no downtime deployments. And so the more persistence kind of components that you actually have, the more you actually have to think through these kinds of problems. You don't want to lose data. You also don't want to compromise the consistency guarantees that your particular data store actually needs to provide to the applications. But also, it's not free just transferring bytes over the network in terms of time and things like that. So we do have to think about these things, and as a consequence, we wanted to choose a stack that was both able to update in place in terms of software updates and also allow us to do immutable infrastructure. And that was one of the reasons that we kind of settled on the Nix ecosystem as a whole. At least the lower two layers, Nix package management and Nix OS. So I'm just going to talk a little bit about the core problems in terms of software delivery. The core principle, which I think most of you will be very obvious, right, what that core principle is. And then I'm going to introduce kind of the basic Nix ecosystem. There'll probably be more of that in Eric's talk later today. And then I'll talk about how Nix solves the specific problems that I mentioned at the beginning of this talk, which is, we've got repeatable development environments, consistent CI dependencies, and the third is predictable deployments, and being able to understand, what is going to happen when we do actually deploy. So, and some of our lessons learned so far, and we're still learning. Okay, so software delivery. Environment provisioning is not repeatable in practice for a lot of different tool sets, and that's a little bit of a problem. We have developers on OS 10, we have developers on Linux, we have people, using one version of Erlang or one version of the JRE and another, and people develop in that way, and then by the time they've actually pushed through their changes to integration or staging environments, then they see problems that they probably should have seen on their local environment in the first place. So we wanted to really solve this as best we could without forcing everyone onto the same operating system with the exact same version of everything and locking them down, because that was also something that we didn't think was advisable. And in terms of CI builds, continuous integration builds have dependencies, so the version of Erlang or some build tools, just only build tools that actually aren't in the runtime that you're actually deploying to. You might need specific versions, and you want to be able to use those predictably in your CI builds, and you want to use the right version every time. Now, if you upgrade a version of Ruby, we used to be a Ruby shop, so we still have a lot of Ruby code. If you need to upgrade Ruby and you submit your changes and the CI server kind of picks up those changes and it's still got an old version of Ruby, that it'll maybe fail in gross ways, or it won't fail at all when it should have, and that's probably worse, right? So we want to be able to have the ability of the service owner to define these things without any out-of-band kind of changes where we've got someone running chef converge or whatever, Puppet apply on the servers, as an extra step, right? And deploys have unexpected consequences, right? And a lot of convergent systems that we've previously had experience with and we currently have in production today on some of the older systems, when you run dry run or Y run in those, it doesn't catch everything because it can't. And you can't predictably get to the point that you actually want to attain, the state that you actually want to get to. So we wanted to be able to solve this problem. And so we also, at the same time, wanted to optimize for scalability, meaning up and down. So we want to be able to launch clusters whenever we want for performance testing, and also to be able to rip them down whenever. But of course, reliability, right, is also the core tenet here. So what yields reliability? I think the ability to reason about your code in some ways, right? Well, so what allows you to reason about code? And I'll probably out myself here. I've been doing a little bit more typed work lately in Haskell, so I'm going to say, this is my claim, referential transparency. And it's really, we're going to do a quick refresher. I don't think there's anything controversial here. I just wanted to put out there what I mean by this. So in Erlang, we have functions. They have inputs, right? This is nothing controversial. We have an arity of 2 at the top, myad, and an arity of 1. And in Nix, we have define inputs for the package. So this is a particular package definition, and we've specified 4 inputs: the standard M, fetch URL, GCC, and help to man for this particular package. And we've also defined build inputs. So at the bottom, they're on line 11, if you can see that. It's the second to last line. And those are what is actually needed during the build process, right? So, of course, if we send in the inputs to these functions in Erlang, we get back results. And the same thing with Nix. When we provide those inputs to the package definition, As you can see, lines 6 and 7, so we've got hello equals import in the middle of the screen. We've actually supplied the variables, which we're inheriting from the Nix packages channel. And if you're worried about trying, I hope you can just take a leap forward and just trust that this is kind of valid, apart from the backslashes. That's for formatting here. But there'll be resources that you can actually look at later on for the actual syntax and try and walk through some of those exercises. So the inherit standard dev, fetch URL GCC, and actually there's a typo here. I haven't put help to man, so that's on me. And so here at the bottom, second to last line, we're just calling hello, and we actually see that it's returning a specific result. In this case, it's the representation of the derivation in the Nix package world. And then if we do the string interpolation on that value, we actually get the Nix store path. And this is, I've truncated it, so the ... actually represents SHA hash. And the way that that's calculated, and Eric may be talking a little bit more about that later today, is it looks at all of the inputs. So it looks at the build script itself, how it's configured. It looks at all of the dependencies, transitive dependencies, and it takes a SHA of that in a specific order. And so that way, we've removed shared mutable state on the file system, and that's, I think, a good thing. So we, at the second half of the screen, we're just doing a build from the command line. And we're passing in the arguments. It's a little bit messy, but I wanted to show working code in here. You are importing the Nix packages and then just traversing to the attribute standard env and so on and so forth for fetch URL, GCC, and help to man. And at the bottom, we actually get back the path, the Nix path that's actually built with all of the binaries inside of it. And so we only depend on inputs, right, for referential transparency. This is just the referential transparency refresher. And yes, we can see that variable z is unbound, so we can't move forward, right? That's from an Erlang perspective. And then what would happen if we remove the help to man from the top of the inputs in our Nix package definition? Well, actually, it errors out immediately, and it says undefined variable, because we use it later on in the build inputs, right? So that's what we would expect, and that's a good thing. We want it to fail when it can't do anything reasonable, right? So what if we removed it from the build inputs? Well, we can run the Nix build command, and we even pass in help to man, right? But after a little while, it's actually going to fail, right? And this is also what we expect. And we only have the driver, the derivation path that's actually written to. We don't have an actual Nix path because it failed, right? So this is kind of what we expect. And so, and of course, the same result. We want the same result given the same inputs. This is a trivial property for simple functions, and just something, I think that's proper, right? And then in Nix, every time that we build the exact same definition using the exact same version of Nix packages for our inputs, we should be getting the exact same path every time, and we do. So, okay, so the big idea is referential transparency. This gives us reliability, and we can actually reason about our configuration and our packages. And as one interesting side note, there's an extra property that Nix provides, and that is anytime that you change any part of the defining parts of the package, you actually get a different result, as in a different path. And that's actually really useful because you want that kind of guarantee. So, questions so far? Okay. So, mainstream package management, it's based on shared and mutable state on the file system. And this is how I feel when I think about that. And yeah. So the alternative approaches are different phases of it. Should be shared and immutable or private and mutable. You can use, expensive coarse-grained locks, not advisable, or you can use a hybrid where you're using finer-grained locks at the critical moments where you actually need to update things. And this is basically what Nix is doing underneath the covers. In terms of when it's trying to build the package, it's got this private and mutable area for doing the actual build. And once it's actually finished the build and it's completed, it goes into a shared but immutable location. And then the point at which is it actually introduced into your profiles to be able to use the binaries, that's using the atomic operation of symbolic link, right? And so that's a fine-grained lock, basically, right? And so we define all of these inputs. That's a critical piece of this. We want to force clean build environments, and RPM and Deb, my experiences were that they did an okay job. They tried their best. Inevitably, there was some kind of pollution, and it would always come up at the most inappropriate times. So we haven't had that experience yet with Nix, and in fact, by definition, that's a bug in Nix, right? So that's not necessarily a bug in RPM or Deb packages. So so that includes the full dependency, like transitive dependency tree as well. So it ensures referential transparency by doing these things that I described, having the private mutable space and defining all of the inputs and things, and then doing the symlink at the very end with the atomic operation. So the Nix ecosystem, just very quickly, there's an expression language. There's a package manager called Nix. So that's a little bit confusing. The formatting. That's supposed to be angle brackets around Nix packages. And that's the primary channel that you'd actually be pulling from, right, in terms of packages. And then there's the operating system, which is Nix OS. And in terms of modules, so you'd be able to override various settings using modules. That they're called Nix OS modules. And then provisioning, there's some support for some cloud providers with Nix Ops, and we'll talk a little bit about that later. And then so there's an orchestration piece, which we haven't really done very much with at all. We've just looked at it. Potentially not quite finished, but it looks very promising, which is DisNix. And CI, on the CI side for package continuous integration, there's Hydra, which supports like Nix channels and stuff like that inherently. So repeatable dev environments. Let's just, there's a tool that comes as part of the Nix package manager called Nix Shell, and it allows you to specify packages that you actually want to load up into an environment. Here, there's a specific package called Erlang release 17 underscore ODBC, and it actually goes out, retrieves those source files and then builds them locally, or it will try and retrieve them from a binary cache, and if they exist in the binary cache that you've got configured. And then, of course, when you start up your Erl shell, you will see that you're using the version that you actually want to be using. And of course, if you do this with a different version of an Erlang release, you'll get the right version when you run Erl once you're inside of this Nix shell, right? And so, okay, that's sort of useful, but can we make this more extended? Well, so this should totally work, except the N at the very end is Nix OS, or Nix packages, I think. Sorry about that. So here we've got we're hard coding, well, not hard coding, but we're setting the permalink to a versioned Nix channel, right? And pinning your channels versions is kind of a good thing to do, I would say, right? Unless you're doing this only for your desktop, right, or laptop or something like that. But in terms of servers, you should really be pinning down your versions. And this will just be a snapshot. So unlike our Yum repositories and Deb apt sources, you won't have to worry about out-of-band updates to the repository, where it might actually be retrieving updates to packages randomly, right? Depending on when you actually run it, which is part of the problem with Yum and apt repositories. So then when you, assuming you've got a shell.nix, and we'll see that on the next slide, I forgot to switch them. When you type in nix-shell in the directory, it'll actually go ahead and fetch all of the dependencies that you've defined in that shell.nix file expression. And so let's have a look at what that might look like. So at the very top, the second line after the cat, we're specifying like named arguments. So we've got packages, and then the question mark here is just giving it a default value, right? And then the comma ... is just saying that you can give it other arguments too, but it doesn't need them. It's not naming them in the actual definition of the expression. And then we've got, we're just doing a let binding by importing from the packages namespace, the standard env, and then using make derivation function from standard env. And then inside of here, it's just name value attribute sets, and a named value attribute set. So we've got the name, we define our build inputs, which is basically a list. And here we want everyone to have the same version of Git, right? Because we've pinned down our version of Nix packages in the previous step. And then we're using the Erlang R18 version that's in there. And then we might be using rebar 3 and hex to Nix. And this is something that Eric will be able to talk a lot more about. He actually built that. And your application may actually use Postgres, right? So you'll want to include that. And it's a very specific version because you've pinned down your channel. And then you've got some front-end work that is using Elm, right, from yesterday's keynote. Okay, so also, you can also specify like a shell hook. So you can actually specify environment variables so that everyone has that, and maybe you source in for a development environment the specific file that has all of these environment variables. And then maybe you initialize the database if the data path doesn't exist. And if it does, then you start up Postgres, right? So that it's already running when you're actually all loaded up in your development environment. And Nix will, as a package management tool, theoretically works on OS 10 and a variety of different Linux distributions. So you don't have to use Nix OS, although our experience is that OS 10 support is sometimes problematic. So your mileage may vary. So that helps us define, repeatable development environments to some degree. We can even create VirtualBox VMs from that previous shell.nix, right, if we want to, and we can distribute those, and that will have anyone that has a VirtualBox running on their computer will be able to load that in, that image in. And so from consistent CI, we can actually load in our dependencies very much the same way using Nix shell as our shebang in our CI scripts. And you'll see here on the second, underneath the primary shebang, we've got Nix shell -i, and then we give it a name value pair. And the URL will be whatever permalink to the version of Nix packages you want to use, so that you're locking it down. And then you can specify all of the packages that you're going to be using as part of this CI script, and it'll load in the correct dependencies for you. So if you upgrade the version of Postgres that you're using, you can actually make sure that you're testing against that correct version. Or if you're upgrading your version of Erlang, you update it here as well, right? So you don't have to do out-of-band CI builder or CI server kind of updates. This has been a pain or a thorn in our side when we've got so many services that have multiple stacks at Lookout. And then you go on and do whatever it is you need to do, your rebar 3 clean, compile, dialyzer, and then you start up your database, and then you run your common test suite or whatever it is. So from a CI dependencies perspective, as long as you pin down your channels, we get this application source and CI script consistency. This is kind of a big win, I think. At least someone who's been asked to update CI build service with the right dependencies for specific applications. We get to update our CI build dependencies. Yes, alongside the app code. So anytime you change your app code dependencies, you change the CI scripts because everything's inside of the source repository. And this is actually a big deal for us. We don't want to depend on anything outside of the repository. That has to be our source of truth. It's the only way that we see as getting to a more self-service kind of model for our developers. And of course, no out-of-band converging on CI build hosts. So predictable deploys. With Nix and Nix OS, we're able to do a diff on the path tree. So anytime that we build the configuration for our Erlang application or our Ruby application or service or whatever, we can actually see all of the requisites for it. And so, it'll be many, many paths. And we can actually compare it to the previous deployment. And we can actually see which packages have actually changed because the hashes will change. And that kind of gives us a better understanding of how, what's going to happen if we do update in place, or if we don't update in place, how might it actually play out once we add those nodes to the cluster. In Java land, sometimes if you're using certain versions of different versions, considerably different versions of the JRE, and you're joining them to a cluster, that may result in problematic things, right? If you're doing something weird with the class loader and it's using a different version of the class file version. And so, so this gives us a better understanding of what's much more likely to happen, right? We can actually test NixOS module logic. So we've written some NixOS modules internally for a variety of things. We're probably going to be open sourcing some of the open source based stuff like Elasticsearch and stuff, since now that's fairly hardened. But we can actually have VMs that are just launched inside of our CI hooks that will go ahead and launch multiple VMs and make sure that they join the cluster together, like in Elasticsearch. They'll join on the unicast configuration, and we'll ensure that those kinds of sets of configurations work as we expect, right? And then we can do some kind of security auditing in a more understandable way for me, anyway. So we'll take a look at some of this. So we can have a look at the requisites of our project path, our project's build path, and we will get a really long list. And then we'll be able to see everything that is required for that to get deployed. So we'll be able to do the diff. And in terms of machine configuration, it's fairly simple. It looks fairly similar to, it's the same language. It's just a simple expression language. We can set syscontrol variables fairly simply, right? Nix OS will actually take care of applying these, and we actually get rollbacks, right? Which is a nice thing. I use it on my laptop for development, and I screw around with my kernel all the time now, and I would never have done that before. So I know that I can just go back to a previous generation of my configuration that I know was working, and it just works, and I don't have to worry about what has polluted my environment. And simple things like networking host names and firewall stuff. We can set our NTP servers, and we can do simple things. It's an expression language. we're just using map here, and we can enable Zookeeper as a service, and the implementation of that module, this is basically using a module, and the implementation of that module is fairly simple to understand. And I'll point you to documentation where you can have a look at how you can implement your own NixOS modules. Okay, so we want to be able to test our machine configuration, and we can do this fairly simply by, we've got our Erlang project, and inside of priv nix, we've got our config.nix maybe, right, which is our source of truth for specific kind, like our app node, right? And then we can just do NixOS rebuild, and then build a VM, and then we can actually launch that VM and maybe run some tests on it, right? That can be and I'll show you some of the not so pretty language that we can define those tests in, and that's an area that we'd love to see improvement on and be able to get to ourselves. We can even set the target host to a totally different host that we actually have credentials for, and it will actually build by default on that target host all of the dependencies, and then activate that configuration that we've passed in the environment variable NixOS config here to that target host. And so in terms of integration testing, we just define a number of different nodes for maybe Elasticsearch, for example. It's just key value pairs, right? Elasticsearch.enable, we're enabling the service here. We're setting the JRE that we want to use, and actually I got them wrong, sorry. That should be the package, and then the JRE and other considerations for that particular service, right? And the provider or the implementation of that NixOS module will offer you those options, right? And describe what those options are for you, the public interface to that. And then it will take care of defining the systemd service configurations and user and group kind of setup and things like that. And here we can actually define in, dare I say it, Perl. Yes. We can define tests for our hosts. So $ES0 and $ES1 are actually machines that we've defined. And they're just Nix expressions for the machine configuration. And we can say startup, startup all hosts at the very beginning outside of the subtest. And then we can just say, hey, we want to wait for this unit, this systemd unit to start up, which is elasticsearch.service in each case. We want to wait for the TCP port 9300 and with a timeout of 60 seconds. And then we want to be able to eventually curl 9200 port at slash and make sure that that returns like a 200 or whatever. And so we can define all kinds of these kinds of tests. I'd love a better, more declarative language for this kind of stuff, but we're able to test our infrastructure in this way, and we have this in our CI jobs, and I love that. Right, that's something that I've seen service spec not really quite get there to the level that we've seen with NixOS testing integration. And in terms of security auditing, we can actually have a look at all of the paths that are required for a particular package. We just pass in the path to that package that we want to check out. We can get all kinds of information. And if we wanted to see, what version of OpenSSL any of our packages might be using, we can do that, right? And just a note that if you have two processes, Erlang processes that need different versions of Erlang, you can have them talk to the right version of Erlang on the same host, not in a container, and not, you can just do that without pollution if that's interesting. I don't know if it is, but. And so we've got some trade-offs, right? So provisioning is not solved. NixOps is a cool tool for like VirtualBox and some other kind of cloud providers maybe, but we're in AWS and we use a lot of AWS primitives. Its coverage is lacking. However, its biggest competitor, Terraform, even though it has perhaps better coverage, it's still not the coverage that we'd like. And the language, Nix, is way more expressive than the Terraform HCL language. It's quite brittle in our experience. So, for example, being able to do striping over availability zones, we might have 2 availability zones in one region and 3 in another available to us. We would have to hard code in HCL for the different regions, and that does not seem like appropriate to us, right? But Nix as a whole, the ecosystem is a steep learning curve. The docs are a great reference, but it's not very good for newbies. And if you kind of came to Erlang 5 or plus years ago, this may not be a problem for you at all, right? But I think slowly the Nix kind of documentation is getting better, right? But the reference documentation is really good, but you have to know what everything's called, right? And that's ultimately the problem. It's got good coverage of the documentation. It's just you have to know what it's called in the first place to be able to search for it. So there was some upfront setup, and it's different from our existing environment. So we had Ubuntu, and we were just using, whatever canonical apt servers, right? We didn't even properly manage that part of it, so that we could keep the right packages and versions and stuff. And we had to do Nix channel sort of releases, and we had to set up the binary cache, and we had to figure out how we audit our packages for each of our deployments so we can actually search through for security audits and stuff like that. So whenever there's a new fix for OpenSSL, right, our favorite, and we can actually go through and grep. Basically, at the moment, it's just grepping for the appropriate version or the vulnerable versions of OpenSSL, right? But it works, right? And that's a lot better than what we had, right? And so I don't know. It's still a lot better. Pretty primitive tools, but yeah. And then. So we've defined in a simple expression language repeatable dev environments to some degree, and you can make that even more repeatable with deploying. We could even construct Docker images if we wanted to, or VirtualBox images and things like that. Not just using Nix shell, right, and the Nix tooling. We have now consistent CI scripts along with the application code. And we have more predictable deploys, right? So we can actually see exactly what is going to change if we do an update. And if we don't do an update, we also have that information too. Once we join those clusters, if we need to, is it going to cause a problem and things like that. And we actually get real rollback. And, as with most things, nothing's actually absolutely perfect. But we haven't found a scenario where we've found this to fail. And rollbacks or downgrades, yum downgrade or things like that, always failed for us, very often. So it's really simple at its core, and that's actually a huge win. Once you understand the primitives, it's just the same thing all the way up. And it's a really simple expression language, right? So what's next? We need to be able to do, well, from our perspective, we need to work on AWS provisioning and make that a reality, a better story in the Nix world. We really like the idea of being able to define our infrastructure in Nix, or at least something as expressive as Nix. Simple, but expressive. And HCL really is not it for us. We're also working on an Idris to Nix backend. That's maybe a bit more of a, because we're silly. But also, if anyone's interested in bundling the Nix package manager on BSD, like FreeBSD or something, please let me know. I'd be very intrigued about that project, and I'd perhaps want to help out. And then maybe we could even target Nix on the beam, right? If you wanted to be able to interpret Nix and compile to beam bytecode. So we've got the Nix manual for the packaging, right? There's also the Nix OS manual. I've put together like some cookbook kind of stuff on this funops.co/Nix-cookbook. I'm going to be adding a lot more to it. This is some of the internal documentation for our infrastructure engineers that I've kind of taken the Lookout specific stuff from and kind of made public. There's a few more articles that I want to put out there. So that's had some positive feedback in terms of accessibility for new people, right? I provide like mappings between the concepts in the Deb world, the Ubuntu world, and the CentOS world, so that people kind of have a better understanding of what maps to what. And there's Nix Pills by, I think it's Lethalman. Isn't it Lethalman? Yeah. So he's got a blog, and there's maybe 26 or 30 pills, as he calls them, which are blog posts about specific parts of Nix, whether that's the language or the packaging system or Nix OS or Nix Ops. And he's a contributor on Nix Ops. Questions? Yes? Yes, Utrecht, I think, Utrecht University. I can't remember the... Yeah, Utrecht, is that right? Yeah. And there were actually 2 or 3 different dissertations from it. The package manager was the first one, I think, and then someone did a dissertation or thesis on Nix OS, like using Nix as the premise. And then I think DisNix was another thesis.
The theory was great.
Yeah.
Is the practice as great as the theory says it is? Because if so, it solved the...
Well, so Nix OS and Nix we're very, very happy with. Nix Ops and DisNix we haven't seen as promising yet, right?
I mean, it's like, if I run on my MacBook, Apple up says, do you want to automatically upgrade the libraries during the middle of the night? And it can totally break everything.
Yeah. I use this on my MacBook, actually, Nix OS, and I've...
What, in a virtual machine?
No. Like...
that's the next one.
Yes, yeah.
Blown off,
Yes. But
on iTunes.
Oh no, I use Spotify, so yeah. But actually, if you're interested, MacBook Airs have good Linux support for the hardware, like the webcam and stuff. My webcam doesn't actually work because there's no Linux driver.
Do you get explosions in? I mean, if you change one bit there and you've got a complete application, does it sort of diff it so that you get an explosion in the sizes and things?
The build, yes. So if you change the dependency and it has a lot of transitive dependency changes underneath it, that can result in a larger rebuild. If
and things like when you compile LM files, the timestamp put in, so it's not identical.
So there's actually work that's been done already to actually remove that because it's not actually used for operation, and that way you will actually do get the same result each time.
There are compilers whose code quality depends on time. Few improvers sort of say, well, if you gave it 10 minutes to compile, it would produce different code if you gave it 5 minutes to compile. So the builds are not reproducible.
Yes, yeah. It's definitely not perfect on that front. Yeah, no, great question.
But I mean, it seems to me this is one of the really difficult problems that needs to be solved. If we have the Internet of Things, all these billions of things, you've really got to know what's on them.
Yeah, absolutely.
So it's a really difficult problem.
I have time for one more question. So you said so you drink the Kool-Aid, sounds wonderful, but you said it's hard for newbies to figure out. So what's your recommendation on how to actually start to learn Nix? Start with what?
So I wouldn't, I mean, unless you're a Linux person already, if you're on OS 10 or whatever, you can just download the package manager and see how well it works. Like if you're on OS 10, I make no guarantees. I haven't used it on iOS 10, but I've heard some people not terribly happy on it.
I think the writing's a good steep learning.
Yeah. I look at the Nix cookbooks. I'm accepting pull requests, but I am trying to make that as newbie friendly as possible. So as people that are familiar with different Linux environments, like the RPM kind of stack and the apt stack, hopefully I'll provide some better context as to how these tools map to the Nix tools, because they're not completely one-to-one. But yeah. Well, thank you.